Today we are going to talk about the unijunction transistor. We are going to discuss the differences between junction transistors and unijunction. Describe the operation of the unijunction transistor or UJT. Identify the leads of a UJT. Draw the schematic symbol for a UJT. Test a UJT with an ohm meter. Connect a UJT in a circuit. The unijunction transistor or UJT is a special transistor THT has two bases and one emitter. The unijunction transistor is a digital device because it has only two states, on and off. It is generally classified with a group of devices called thyristors. These devices that are turned completely on or completely off. Thyristors include such devices as the SCR and the triac, the diac, and the unijunction transistor is made by combining three layers of semiconductor materials. The typical UJT structure consists of a lightly doped N-type silicon bar on which the ohmic contacts are provided at each end connection, called the base. B and B2 AP region formed by heavily doped materials is alloyed on one side of a bar close to terminal B2. This P, the region, is also called an emitter E. Suppose you have read the above lines carefully. In this case, you will notice that the bar P in junction is formed due to the collision of N-type and heavily doped P region. On the other hand, and RB is the essential resistance of the N-type bar. RBB is the combination of two resistance, RB1 and RB2, where the RB1 is the resistance between B1 and emitter, whereas RB2 is the resistance between emitter base B2. The value of RB2 is small as the base B2 is close to the emitter, base B1 is far from the emitter. RB1 has a slightly higher value of resistance than RB2 in its normal state. Current does not flow through either path until the voltage applied to the emitter is about 10 volts higher than the voltage applied to base 1. When the voltage applied to the emitter is about 10 volts higher than the voltage applied to the base 1, base to path N from the emitter through base 1, current will continue to flow through the UJT until the voltage applied to the emitter drops to a point that is about 3 volts higher than the voltage applied to the base 1. When the emitter voltage drops to this point, the UJT will turn off and will remain off until the voltage applied to the emitter again reaches a level about 10 volts higher than the voltage applied to base 1. The pulse rate is determined by the amount of resistance and capacitance connected to the emitter of the UJT. However, the amount of capacitance that can be connected to the UJT is limited. For instance, the most unijunctions should not be connected to capacitors larger than 10 microfarads because the UJT may not be able to handle the current spike produced by a larger capacitor, and the UJT could be damaged. The unijunction transistor can be tested with an ohm meter in a manner very similar to that used to test a common junction transistor. When testing the UJT with an ohm meter, the UJT will appear as a circuit containing the resistors connected in series with a diode connected to the junction point of the two resistors. If the positive lead of the ohm meter is connected to the emitter of the UJT, a circuit should be seen between emitter and base 1 and emitter and base 2. If the negative lead of the ohm emitter is connected to the emitter, no circuit should be seen between the emitter and either base. If the ohm meter leads are connected to the two bases, continuity will be seen between these two leads, provided that the output voltage of the ohm meter is high enough. Tomorrow we'll talk about the SCR or silicon controlled rectifier. Thank you for watching and please remember, like, share, and subscribe.